Welcome back and thank you for joining. Let's continue with example number 1. Recall that we were given the vertices of a triangle A, B, and C, and the midpoint of the side AB is M. The midpoint of side AC is N, and we connected the two midpoints, which by the way is called the mid-segment of a triangle. And we proved that the mid-segment is parallel to the third side of the triangle, so to the side BC. So in question B, now we have to prove that MN, so the mid-segment MN, is half the length of the side BC. So let's get started. So first, we'd like to write whatever we're asked to prove. And we're asked to prove that the length of MN is equal to the length of BC divided by 2. So this is going to be BC and then divided by 2, or 1/2 of the length of BC. Now, we're going to continue with writing out the formula for the length of MN and the formula for the length of BC by simply using the length of a line segment formula. So for MN, we're going to have equal to the square root of, we have x at m minus x at n raised to the power of 2. So always the coordinates from n to m, difference, square it. It's just like Pythagorean theorem. And then plus y at m minus y at n raised to the power of 2. And we want to prove that this is going to be equal to 1/2. The length of BC, which is the square root of x at C minus x at B, close brackets, to the power of 2, plus y at C minus y at B raised to the power of 2. So we know the coordinates of M and B and C, so we'll substitute. So that would be the square root of -1 minus 1 to the power of 2 plus 4 minus 0 to the power of 2. Remember that we got the coordinates of M and N in the previous step right here. So basically we go -1 minus 1, 0 minus 4, or we can either go 1 minus -1 over 4 plus 4 minus 0 here. Now, next we have 1/2 of x at C. Now we have x at C minus x at B, 5 minus 1 to the power of 2. And then plus, now we're going to do the y's, +2 minus -6 raised to the power of 2. So in the next step, we are going to simplify each side. So remember, -1 minus 1 would be +4, because the sum here is -2. The entire thing squared is 4. 4 minus 0 is going to be equal to 4 squared, or 16. On the other side, we have 1/2. 5 minus 4 will be 4 squared, and 2 minus -6 is 8 to the power of 2. So next, we are simplifying each side. Remember, don't take terms from one side to the other. We have 4 plus 16, the square root of 20, equals 1/2 of 16 plus 64 is 80, so square root of 80. So we're going to simplify each radical. This is an entire radical. We're going to turn it to a mixed radical by taking out any perfect square factor. Now remember, perfect square factors are 2 to the power 4, 2 to the power 2 equals 4, 3 squared equals 9, 4 squared equals 16, and so on. So in number 20, we see that we have a factor of 4, which is a perfect square factor, and we'll multiply it by root of 5. So root 4, root 5. We know that we can split them up, right? We have learned how to write the product of the roots. Then now we're going to have 1 over 2. Now we have to think of breaking down 80 into two factors, one of which is a perfect square. So again, I'm going to go over perfect square numbers, which are 4, and then 9, and then 16, and 25. And I will try to divide 80 by each of these numbers and see which one works best. So if you divide 80 by 16, use a calculator for this, you will get 16 times 5. So therefore, we're going to break 80 into root 16, root 5. So root of 80 into root 16, root 5. Now, simplify some more each side. So the left side becomes 2 root 5. And the right side is 1/2. Now, root of 16 will be equal to positive 4 and then root 5. Very optimistic to see root 5 appear on both sides now. Simplify the right side a little bit more. So 2 root 5 is equal to, you can simplify 4 and 2, and then we get to root of 5. And therefore, we're going to say that the two sides are equal to each other. So 2 root 5 equals 2 root 5. And remember where we got this from? From simplifying the length of MN equals 1/2 the length of BC. So that proves that the length of MN, or the length of midsegment MN, is indeed half of the length of BC. So I'm going to write the final statement. Therefore, MN equals 1/2 of BC. And that's how we prove that the midsegment of a triangle is equal to the length of the other side divided by 2. So to summarize both these two solutions, we're going to say that the midsegment of a triangle actually satisfies two conditions. Number 1 is parallel to the other side of a triangle and half its length. And this is one of the most famous theorems in geometry. So I hope this made sense. And thank you for learning with me. I invite you to continue trying the next question. Try this on your own first, and then follow with the solution. Bye for now.